Hi everybody, we are the group doing this Ghissi Alterpiece virtual real-time rendering for the North Carolina Museum of Art. So this here now we have a image picture. So yeah, this is the painting that is in the museum, and as you can see, there are some textures on the painting, and there are also punctures on the painting to create the dent effect. So what are we doing for the final project is to create this 3D effect for the shining on different pixels. So we have this theorem called Phong reflection model, and this is to calculate the lighting density at different pixels according to its denting features. So that each pixel, the light intensity on different pixel is calculated by the sum of the ambient constant, the diffuse light on it, and also the specular light on it. So the ambient light is just the constant that we set. And diffuse light is the diffuse light and the specular light are calculated by the light source vector and also the normal vector. So this is a picture to show how it works. So we have, this is the light source. This is the normal. So according to this normal, this is the reflection light, and this is our eyes angle, and then so here is how we calculate all the stuff. So for the diffuse light, we only need the light source and the normal vector, and the light intensity is related to the cosine angle of these two vectors. And for the specular reflection, we have this light source, and then we calculate the reflection direction vector according to the normal, and V is our investigation angle, and then the specular light intensity is calculated by the cosine value of this reflection direction and also this V vector. So this is the theorem that we use for our final project, and here I'm introducing Yuhan to show you how it works.
So here I'm introducing the final project. So here is a browser that we use to render the real-time Ghissi Alterpiece. So actually, according to what Mingxuan said, we're using the Phong model lighting to show the Alterpiece and the WebGL. So let's reload it. And here we can see we use a point light, and we use the keyboard and the mouse to drag the model, and we can use the keyboard to control the camera. We can zoom in, zoom out. If we zoom in, we can see there are little cracks on it. That is like something you can really see when you're in at the museum. You can see on the browser, and we have the lighting effect here, and we can change the location of the lighting exactly as what you can do in the museum. We change it, and we can see the different effects. Let's go back here and zoom out a little bit. Yeah, so here is our model to render the Ghissi Alterpiece online, and this is a real-time rendering.
So by changing different angles, different camera angles, we simulate the fact that people are walking around this painting, so that at different angle around this painting, people can receive different light effects from this painting. So this is what we already have right now.
So actually, we learned a lot from this this project. We know how to use the WebGL to do the real-time rendering, and we would like to show the code of this project.
So there's one piece of code that we implement the theorem that we just mentioned about. It is here.
So actually, according to the phone model theorem, we're calculating the light direction, and we're calculating the normal according to the light direction of the surface. And here is our the specular light weight, and we calculated according to the phone model theorem and the related functions, and we added them together. And here, finally, we get the fragment color, which is really the RGB, the colors of the lighting of each pixel. So here's where we render the pixel.
Okay, so as I just mentioned, so this specular light is actually calculated by the eye direction and also the reflection direction. And the specular light intensity is related to the reflection vector and also the eye vector. So this is how we get this specular weighting. And also the diffuse weighting is just calculated by the light source and the normal vector. So this is the kind of like the core algorithm that we have for the lighting intensities. And the rest of code is just setting up the web browser stuff and the constant settings, buttons, all of them.
So this is our project of the Ghissi Alterpiece, and thanks for watching.
Thank you.